Okay, first, before we get to depressurization, you have to understand that whenever there's incoming pressure, as long as there's support on all sides from pressure, then that pressure will get resisted by the supporting pressure, and that will prevent the pressure from going towards the resisting pressure. And if there happens to be a way of containing it on the rim, which we'll get into a little bit later, it will end up trapping that pressure, and this will basically be a unit. That's how units form. So a unit of pressure is simply a cluster of different pressures that have all been trapped under a special rule, and they maintain that interior through combating for room because they're all pressurized. Oftentimes this will form patterns. Those patterns will become relevant probably in the next chapter, right? But the patterns will be introduced in this chapter just in a few sections from now. Now, whenever you have a cluster inside of a pressurized unit, oftentimes the very center will be the highest pressure and everything around it will be lower pressures, right? And the very rim will be a value of 1, which we'll get into a few lessons. We'll explain in a few lessons. Now, in order to calculate exactly whether or not depressurizing units will interact with one another, you need to consider a percentage diagram, which is comparing the lower number to the higher number. What happens is you create these percentages that correlate with exactly how many units this will move before it interacts with one of these. So if you have this 400% for 3, that means that the 12 has to be 48 units away from 3 for 3 to actually interact with 12, and then for the 150% it has to be 16 units away, right? The 8 has to be 16 units away from the 12 in order to interact with interact with it. If it happens to be less, the lower numbers will be ignored and the universe will immediately try to get rid of this. It will ignore all of these and will just try to get rid of this. If there are any lower numbers that are not far enough away to actually interact, it won't even bother. And oftentimes whenever you have an interaction, these smaller numbers will actually drift. Okay? So essentially this 12 says move out of the way. I'm bigger and I want to expand more. Okay? Now, exactly what do these numbers mean? We'll get into that in a little bit. For now, we'll look at a smaller number compared to a bigger number in this one, and notice that's 25%, which means that there's going to be resistance going at 4 times this way, right? So the 8 is going to push against the 2, and what that means that if the 2 is not equal to 32 units or more, the 8 is going to push against the 2, and it's going to most likely either ignore it, or if it's far enough away, it's probably going to push it to the side. Okay? So this, anytime a percentage, a number that you're comparing with another number, anytime that's lower and it's interacting with another number, there's going to be resistance. right? So 100% or lower means resistance, right? But at 100%, what it's going to do is it's going to just push against each other, and it's not really going to do very much. This will eventually lead to 1, but for now we're going to kind of ignore that for a bit so that we can get into other explanations that we need to right now. The thing to understand about our universe is that even though I'm drawing slices in circles, it's oftentimes in spheres. It's often three-dimensional, and anything that is not this will expand. So when you're dealing with units that want to expand, this expansion is our perceived time. What that means is all the activity in the universe, every single action that's taken is going to be expansion. And any movement, any interaction, anything that happens in reality is going to just be expansions, right? So if you stop this, you tend to make things solid because they are no longer trying to expand, right? But solids are not exactly solids are not completely expanded. Void is. Okay? So solids, while they appear to be fully expanded, they are not. So even though they don't have any activity at the moment, they will have activity once they have some sort of pressure that comes in. Okay? So we can see that pressure is actually just simply expansion. Well, the universe pushing it, the void together, and we can see that the pieces of void like to fold, do not like to fold at all, which means that if there's no support, it will simply expand. Okay? Now, whenever you're looking at an object in space and you're wondering why it just keeps moving in the same direction, that's because there was initial pressure going this way. The object resisted this way because the internals of an object are at a much higher pressure rate, which means that this object will now be pushing this way. Okay? Because the exterior of an object is 1. Now, if you pierce that exterior, you're going to notice that the value is huge, right? What that means is that while you may not always create a single direction, whenever you push an object in a depressurized zone, you will end up causing the direction to change, right? And the more stable, the less pressure that will be released. Okay, this is very basics. I'll get into exactly what this is in the next chapter, whenever I actually show you how subatomics come together. For now, we're just going to keep it this way. Just keep in mind that there's incoming pressure, and that incoming pressure, if all the other sides are supported, then it tries to go back out. But if it creates a pattern that traps it, it will end up forming a unit of force, and that unit of force has multiple pressures inside of it, and the rate is always a whole number, right? And the size can be anything. Okay? So, whenever something wants to depressurize, you can use a percentage diagram to try and figure out exactly what it is, exactly whether or not something will interact on the interior. Chances are that it won't have very much interaction, but as long as there is a pattern that traps all that pressure, then the pressurized unit won't expand into infinity. And yeah, that'll be the first. Okay, this video is going to be decompression, and the next video I'm going to give some sample problems just to be able to get you to understand exactly what I'm saying, so that you can hopefully get a little bit of knowledge as far as the basics of the universe goes. And if there are any inconsistencies in this one in particular, there may be a few inconsistencies. We'll go ahead and work on those. Well, I will. Anyways, this is the video on pressure.